Okay, so thank you all very much for turning up and seeing me. So my name's David Spiegelhalter and I'm a professor of risk. So here's a risk. Here's this little man. You know, he's suffering the risk of being hit by lightning. That lightning is coming down and it's got 20 forks. It can do left or right. And each one is a 50-50 chance of turning left or right. So if you can think of it, if it turns left 20 times in a row, it's up here. If it turns right 20 times in a row, it's down there to hit there. So, okay, what is the chance that if he stands there on that end, he's going to get hit with a lightning strike? Come on, who's the clever ones? Who's sharp this afternoon? Think of it as a probability tree. It's a half, on each branch is a half. What is it? Half to the power of 20, because it's going to go a half times a half times a half times a half all the way down. And what's 1 over 2 to the 20? Roughly. You know, anyone know that? Yeah, no, it's 1,000 squared. It's 1,000,000. I'm a statistician, not a mathematician, so for me it's 1,000,000. Close enough. It's close enough for statistics. So that is a 1 in 1,000,000 chance of him getting hit. Now, it hasn't happened yet, because we've only had about 1,000 strikes. But if we waited long enough, it would happen. I can guarantee you it would happen. We'll have to wait rather a long time. And, but if we go and stand him in the middle, then we can just wait. And this is when nothing ever happens. You know, he's not going to, he's going to get whacked all the time. And the lesson for that for us all, ladies and gentlemen, is in a lightning storm, don't shelter under a tree and don't shelter in the middle of a binomial distribution, because it'll get you in the end. Okay, so we'll come back to 1 in 1,000,000 chance later, because 1 in 1,000,000 chance is a nice number to think about. So remember that 1 in 1,000,000. Okay, sex, drugs and sausage rolls. My background, I did maths. When I was your age, I looked like that. When I did maths, that's what people looked like then. And then I went to do maths at university, pure maths, and I looked like that, because that's what people looked like then. And then the pure maths got too difficult, so I changed to statistics, and then I look like that. And look at me now. This is what 40 years doing statistics makes you look like. And so basically I'm here to give a talk, but actually what I'm here to do is to try to inspire you, or try to enthuse you to go on and do more maths. Because maths is cool. In particular, I'd like you to do probability and statistics, which a lot of people are not that keen on. That's why I teach in Cambridge. I teach the introductory statistics to the second year maths students in Cambridge. And it is great. It's a fantastic subject. It's just growing and growing. The whole data science, big data thing. It is the job of the future. You can earn trough loads of money if you want, or not. You can just do good things if you also want as well. So that's, okay, end of plug. But I'm actually, just to show you can earn trough loads of money doing maths, I'm paid by a hedge fund, Winton Capital Management. They pay my salary. And they make pots of money by doing cool maths. And we got this website, Understanding Uncertainty. We do blogs, and I get involved in all sorts of stuff, all about uncertainty and risk. Actually, this is the other thing. It's coming. We've written a book on teaching probability in school at GCSE level. And so we're rather proud of that. It's coming out this year. And I've just written another book as well. That's my other book, Sex by Numbers. Now, I'm not going to talk about that. Some of you may wish I was, but I'm not going to talk about it. Actually, some of the material is going to come in this talk. But that's a book about the statistics of sexual behavior, which, no, I better not talk about that. Might get complaints from the parents. Okay. And the other thing I've done is that. Do you recognize that? Okay, who does recognize that? Oh, most of you, good. That is the Wipeout course in Argentina, just outside Buenos Aires. And for those of you who know, it's a sort of idiotic endurance test, really, where you compete, and 20 of you fly to Argentina for the weekend, and the winner comes back with 10,000 quid, and the others come back with bruises and broken bones and things like that. So would you like to see how I got on? You're going to anyway, tough luck. Oh, no, before that, I'm going to say that being a statistician, before going on to that course, I wanted to find out, I wanted to train in the right way. So I looked at the data. Okay, now for those of you who don't remember it, the point is that there's 20 of you join in, and the first 12 get through the qualifier, go on to the next round. So all I want to do is get through into the next rounds and not to be embarrassed. So this is the number of minutes for getting through the qualifier that people took on the qualifier. You can get all this data off Wikipedia. So, about 3 minutes, the median is just about 3 minutes. These are the people who end up sort of sobbing in the mud, and I didn't want to be one of them. So I thought, okay, that's it, 3 minutes is the median, but that's not the most important thing. The important one was, what does the 12th fastest person take? because that's what you have to. You have to be in the top 12. So if you look at the time of the 12th fastest person in each round, the slowest qualifier, look over the past 4 years or so, that was the data it showed. And after the first series, where the course was longer, it's really stabilized at around about 3 minutes. So I knew that I had to do 3 minutes work to get through, and I trained proper seriously to do 3 minutes work. And this is how it ended up. Oh.
Wow! This is incredible. The total wipeout course, it's beautiful. Look, down there. Is that 20 ordinary everyday Brits, including a railway engineer, a poker player, and a penguin keeper? I can see waving.
Now, this is Professor David Spiegelhalter, OBE, and he's a professor of risk.
What this means is that if I'm going to qualify, I've just got to get below 3 minutes.
Yeah, right. Below 3 minutes is the key. And off goes the professor towards the nasty snowballs. Yes? Yes? Uh-oh. Yeah, I know what he did there. He followed the y-axis when he should have followed the x. On to Granny's house now.
Little maths
destination.
All right, Professor Spiegelhalter.
Oh! Yeah, he could still be doing this in under 3 minutes. All he has to do is clear both logs. Ow! Big ow!
The gentleman doth profess too much.
Despite that risky performance, Professor David Spiegelhalter, OBE, climbs to the finish in 3 minutes 17.
Got to be in the top 12.
Just shy of his time.
Got to be in the top 12.
Taking the lead, it's Suspicious Helen, followed by Saxy Fiona and Carolyn from Outer Space. In fourth, it's Ball Crossing No Meat Marina. In seventh, Rob Boy. And scraping it through to the next round are Professor David Spiegelhalter, OBE, Ali the Penguin King, and Guinea Pig Mel.
Right, okay. So I did it. I managed to get through the qualifier, and so I'd achieved my aim. And again, if you're very good, I'll show you how I got on in the next round. Okay, so that's what I did. Now, people have trouble with numbers. There's a nice example of Tesco having trouble with numbers, where pomegranates are £1 each, with this great offer of buying 2 for £3. So if you want 2 pomegranates, what do? It's really a deep philosophical issue. So we can look for that sort of thing. Now, one of the things I've done was make TV programs about numbers and chances, and they said you've got to do something dangerous. And I said, oh great, can I swim with sharks? Because Brian Cox got to swim with sharks on one of his programs. And they said, no, you're not Brian Cox, and we've only got 300 quid. I have to say, as a little aside, when you start making BBC programs, you realise there's a big division. There's Brian Cox at the top with his helicopters and his mountains, and there's everybody else with a few hundred quid, and you never leave, never go very far at all. Anyway, I did get to jump out of a plane. So I did a tandem skydive where they strap you to someone and push you out of the plane, and that's it. So that was considered a risky thing. So how risky is that? What's more risky? Doing that or riding 100 miles on a motorbike? 100 miles, 10 miles on a motorbike? Motorbike's still a more risky thing. Right, we'll see. So I wanted to know that, so I wanted to go and look at the data. The biggest statistician, you've got to look at the data. And if you go onto the British Parachuting Association website, and you search really hard, because they don't put this on the front page for some reason, I don't know why really, you find out how many deaths there are. And it's a really nice round number. 4,800,000 jumps, 600,000 jumps, 48 people killed. Almost exactly 1 in 100,000 jumps, somebody dies. Or 10 in a million, they die. Now out of tandems, which is what I did, and about 1/3 of a million jumps, 2 deaths. 1 instructor and 1 student. I think these might have been correlated events somehow. I don't think these were independent, separate events. I think these are deeply correlated. Anyway, so that's a 3 in a million chance of dying. So tandem's a bit safer, I think. I reckon there was about a 7 in a million chance I was going to die doing that. So is that big? That's like standing there and just enduring 7 lightning strikes. I thought, yeah, that's cool. I can do that. So I did it. Now, there's a way, I did it partly because I know what the risks of other things are. I know what the risks of motorbikes are. I know all this stuff. Because if you start comparing risks, small risks, you can do it. But to do it, you need a nice unit of deadly risk. And there is a unit which is a 1 in a million chance of dying. What that guy at the end was experiencing every time lightning strike. And it's called, where is it? A micromort. A micromort is a 1 in a million chance of dying. It's an official unit. Now, is that a lot? Is that a little? Well, it's about what you all experience every day. roughly speaking. It depends. If you're an idiotic, bad... Anyone ride motorbikes here? Any motorbike riders? Any bad cyclists? Dangerous cyclists? In which case you probably experience more than 1 micromort a day. But on average, in England and Wales, 50 people are killed every day, or murdered. So there's 50 people die suddenly every day, out of about 50 million. So average one. Now there's more old people like me who try to climb ladders and do DIY, so there's a high risk for them, and there's a high risk for bad drivers and things like that. But on average, about 1 a day. So jumping out of the plane is about a week's worth. But you can see there's other ways to spend your micromorts. Here we go, let's go and look at this one. Whoops, yeah. So motorbike. Oh no, let's do walking. How many miles can you go for a micromort? A 1 in a million chance of dying. Okay, let's calibrate that. It's around about 17, 20 miles you can walk before you get run over. It's very unlikely to get run over, so it's pretty safe. Cycling. I think cycling's any per distance more dangerous or safer than walking? Yeah, no, it's actually slightly safer in terms of distance. Because you go further distances. In terms of time, per minute, cycling will be more dangerous. But per distance, it's not the same. Now, car, you go miles. It's actually got further now. This is a few years ago. About 300 miles per micromort. And motorbike, 6. Really, motorbikes are dangerous. They got a bit further now, but 6 miles a motorbike. So 7 micromorts jumping out of the plane, about 40 miles on a motorbike. So it's in between that 100. So you're right when you said 100, but actually 10 miles on a motorbike was a bit safer. I actually don't like riding on motorbikes now because I feel it's rather dangerous. So we can, and of course, flying or being in a plane, being in a train, you get zillions, tens of thousands of miles per micromort and those things. So we can, what this means, we'll come back to these later when we start talking about drugs, but we can then compare different activities we will do. Scuba diving is about 5, running a marathon is about 7, hang gliding about 8 micromorts, they're all coming out around about the same. Base jumping, anyone, no, well, I'm not going to ask for any base jumpers here, a lot. If you're going to hurl yourself off buildings or leap off mountains wearing a wingsuit, you are going to pack them in by the thousands. But if that's what you want to do, I'm not going to say no. Okay, so let's look at how, actually, I want to look at, introduce some sort of slightly more technical ideas about probability and chance. But I want to do a little experiment first. And sort of inspired by, you can remember Paul, your psychic octopus? That was years ago. But at every World Cup, they always have, animals that can tell, predict matches. Always this drivel in newspapers and things like that. So what I'd like to know is if there's anyone here, I think there's someone here who's psychic. I want to find out who they are. So I think there's somebody here. I don't know who they are. Somewhere in this room is someone who's going to guess something quite remarkable in the next few minutes. Somebody is going to do something remarkable, I know, but I don't know who it's going to be. So, but what I want then, actually I'm not going to do anti-psychic, I'm going to do psychic. What I want to do is, I'm going to flip it, actually, no, before anything else, I dread to do this like a pantomime. I need a volunteer from the audience. Now, but not just anyone, I need a volunteer who can manage to flip a coin and catch it, who's capable of flipping a coin without dropping it every single time. Is there anybody here? Come on, somebody here will flip a coin and catch it. That's all I want. It's not much. Oh, come on, hands up, somebody volunteer. Come on here, come up here. Come on, James, come on, up here. Yeah, okay. James, thank you very much. We're also going to find out whether James has got a brain. Now, what you're going to do is flip that coin and catch it and look at it. So try flipping the coin and look at it. Great, look at it. And you're going to look at it. Now, what we're going to do is you're going to try to read James's brain. Ooh. So when he's looked at it, you're going to guess whether it's heads or tails. Now, and I want to know who's right. There is a way of doing this. Now, don't make a fuss about it. Keep quiet. Well, all you got to do, okay, I'm going to give the instructions. What you're going to do is stand up and guess what the coin is, and you put your hands on your head if you think it's a head, while you're reading your brain, and then put your hands on your hips if you think it's a tails. On your tail, if you think it's a tail. And then when he says what it is, the ones who are wrong sit down. So the ones who are left are the ones who got it right. And let's see who can get the most right in a row. No cheating. No, I'm not going to play if you're going to cheat. So don't cheat. And actually I can see you. I can see every single one of you if you're cheating. Okay, right. So all stand up. Right, James, flip the coin, first coin. Right, okay, he's looking at it, he's looking at it. Read his brain. Hands on your heads, or don't all do the same thing. Don't do the same as everybody next to you. All right, have you done it? Heads or tails, quick, decide, heads or tails, don't all do the same thing, and the answer is, James, what is it?
Tails.
Tails, all the heads sit down. Right, heads sit down, and again, second time. Okay, James, look at it. Is it heads or tails? Look and don't cheat. Heads or tails? One heads, decide, right, James, what is it, heads or tails?
Tails.
Tails, heads sit down. Right, flip again. Right, heads or tails, guess, heads or tails, are you ready? Are you ready? Guess, read his brain. And the answer is, James?
Heads.
Heads again. Tails sit down. Right, what's that? How many is that? 4? 3. Flip again, James. Fourth time. Right, heads or tails? Heads or tails, have you guessed? 1, 2, 3, James, what is it?
Heads.
Heads, tails sit down. That's 4 times, right. Whoa. God, you're useless. Right, not many left. Fifth time. Who can get the fifth one right? Heads, have you flipped? Flip. Right, heads or tails, guess, read the brain. Don't all do the same thing. Heads or tails, guess, and what is it?
Heads.
Heads. Hey, right. No, stay. That's fifth time, so the sixth time. Right, 1 left. Oh, you are useless. Right, okay. And the answer is?
Heads.
No. Oh, thank you very much. So what was that, the 7th? Was that 6th or 7th? 6th, okay. James, thank you very much indeed. Round of applause for James, a great flipper there. Oh, I got it wrong. The last person sat down on the 6th flip, and I guessed it was going to be the 7th flip. Oh, I nearly got it right. The point is, it should have been the 7th. It's just that you're so useless. Yeah, because if you'd done it if you'd been all flipping coins independently, there's 200 people here, roughly. So, roughly speaking, 100 would have sat down on the first one. The second one would have been 50, third one would have been 25, fourth one about 12, fifth about 6, sixth about 3, and by the 7th, that'll be the last one. They'd be halving each time. But it didn't, it went down faster than that because you were doing the same things. You weren't being independent. You were looking at each other. You can't resist doing it. Don't know. Anyway, so nobody was very psychic there at all. Well done, sir. Congratulations, 6 right in a row. So 6 right in a row, the chance of getting 6 right in a row is a half times a half times a half 6 times is 1 over 64. 1 over 64. So not that remarkable. The point is that with a big group like this, something rare is going to happen. We know that these coincidences are going to happen. And in fact, we can draw a distribution. If you really had been doing it at random rather than slightly correlated, you'd expect 50% to guess wrong, I should say. 50% would sit down on the first one, then 25%, etc., etc. This is the percentage that would sit down each time. And it forms this distribution. It's the waiting time until you get something wrong, and it's called a geometric distribution. It's a distribution that shows how long you have to wait for something to happen. And it's a beautiful distribution. Some of you may have done it already. It's a lovely distribution. So here's the maths of it. I should have changed this. Yeah, I did this before about guessing it right. Pretend you were trying to guess it right rather than wrong. And so probably the first is right as a half, probably the second is first is right, second is the first one that's right, is probably the first is wrong, the second is right as a quarter, and so on, and you just get eighth, and that's where that curve comes from. So it's just, again, like multiplying down a tree, etc. Okay, sex. Sex. Let's get the word over with. Now, what has this got to do with sex? Okay, what it's got to do with sex is if you imagine a couple. Now, there are a couple of mathematicians. They're really sweet. No, they get married. These 2 mathematicians get married. And they want to have a baby, but being mathematicians, they're not very good. They don't really know what to do very much, but never mind. So rather than finding out what to do, they start doing the maths, because that's their natural thing they do, being they're mathematicians. And they look at some data on what is the chance of actually getting pregnant from having sex just once. And it turns out that for young women, if at the time of peak fertility, about 2 days before ovulation during the cycle, it's about 50-50. It's about 1 in 2 chance of getting pregnant. And in some people, it's even higher. Some it's lower. But roughly speaking, at that particular day, if you can pick that day, it's about 50% chance of getting pregnant on average. It's very high. But it drops off quite steeply each side. And on average, if you think of just having sex at a random time, or whatever, if you imagine such a thing, there's about 1 in 20 chance of actually getting pregnant for a young woman just from having sex once at a random time during the cycle. Okay, so that's the statistic. So how long are they going to have to wait to have their baby if there's a chance of 1 in 20 that she'll get pregnant each time they have sex? So that's a waiting time problem. It's like flipping a coin, except this time the probability of success is 1 in 20 instead of a half. Okay, there's some maths. This is about the only mathematical slide. So this is the one mathematical slide. So let's assume some chance P of success at each independent attempt, where P is 1 over 20 for having a baby. Okay, the first success is at attempt X. So X is the notation, it's the random variable that says when do they first get pregnant, the first attempt when they get pregnant. So X has got what's called a geometric distribution, because the probability that big X takes on the value little x means that the first X minus 1 times they failed and they succeeded on the Xth time. So the chance of failing X minus 1 times is 1 minus P times 1 minus P times 1 minus P. And then finally they succeed on the Xth time, which is P. So that's the formula for a geometric distribution. The probability of waiting until time X, when there's a probability P of success at each time, is 1 minus P to the X minus 1 times P. So that's derived the form of the geometric distribution. That's what it looks like for getting pregnant. And the average of that distribution, it's not quite, the most likely time is the very first time. After that, it tails off quite slowly, long tail. Now, it's not quite clear what the average of that distribution is. You look at that, what's the mean of that distribution? Well, actually, it's actually quite tricky to prove. Much easier to use your intuition. If there's a 1 in 20 chance of it happening each time, how many times do you have to wait on average? It's 20 times. It's just 1 over P, so 20. That's the average of the distribution. Can't easily see it because it's not nice and symmetric. It's about 20 times, and the median is less than that. So that's the geometric distribution. When you're guessing a coin, it's a half. When you're getting pregnant, it's 1 in 20. The mode is 1. The mean is 1 over P. And the median is that, log 2 over log 1 minus P. Extraordinary formula. Nice one to prove. I'll leave it up to you. Guessing the coin, it doesn't really exist. The median doesn't really exist in that case. For getting pregnant, it's 14. Okay, so 14, if you have 100 families all trying to get pregnant, the middle one, the one that takes half the median, will be 14 attempts. Okay, so what happens when people get pregnant? Well, this nice couple sort of wanted to get pregnant. Some people don't want to get pregnant, and many actual teenagers don't want to get pregnant. And in 2013, the data, now I'm going to go into statistical mode rather than maths mode, there are 24,000 girls under 18 in England and Wales who got pregnant. And that might seem quite a lot. That's actually 1 in 40 of 15 to 17-year-old girls. 50% had an abortion. The staggering thing is not, well, it is quite a high number. The staggering thing is how much that's reduced over the last 15 years. It used to be double that. That's the graph for the under 18 conception rate in England and Wales. Look what's happened over the last few years. It was stable for quite a long time, for about 30 years, to 1998 it was pretty stable, and then it's just plummeted. Now I can't produce the reason for that. You probably might have a better reason for that, because you're in this age group, a better reason for that than I have. The crucial thing is that one learns from this is that the generation today, your generation, are actually a lot more knowledgeable, a lot more sensible, a lot more competent in terms of their sexual behaviour than people were before. So I think it is quite an extraordinary fact that it's halved very recently. The other thing is that girls, will get pregnant. Why do they get pregnant? We know why they got pregnant, but it's more complex than just saying, oh, they had sex and they got pregnant. Because the chance of getting pregnant is hugely related to other background factors. That's 2 maps of England. One shows the teenage conception rate, getting pregnant, and one shows deprivation. Can you tell the difference between those maps? Would you know which was measuring deprivation and which was measuring teenage pregnancy? They're almost exactly the same. And just another measure and just to show that it's the context that matters in which people live. Now here's a nice one. This is from a few years ago. Along the bottom is each of these is a town or a region in England. This is the percent of girls getting 5 GCSEs at A to C. So these, I'm sure that Reigate is down in this corner. And other places are up in that corner, over there. And that's the percentage of girls in the same age group who get pregnant each year. And there's extraordinary correlation there. Huge correlation with nice sort of nice areas of the town going there, and up at the top you have Blackpool or Great Yarmouth. Hastings. It does tend to be seaside towns for other reasons, and other sort of, really basically deprived areas. For boys, that's the percent of girls. For boys, the picture looks much the same. So the percent of boys getting 5 GCSEs is highly correlated to the percent of girls getting pregnant. So that doesn't necessarily mean a direct causal relationship, but it's there, it's a highly thing. The only difference is, if you notice, that's girls and that's boys, that far fewer boys get 5 GCSEs at A to C. That's the main finding from that. Okay, let's look at, another people have trouble with numbers. This is my favourite. This is my favourite pie chart, because you may spot something wrong with this Fox News pie chart, who haven't learnt their pie charts properly at all. Fox News is you could give a whole talk on the bad graphics in Fox News. Okay, drugs. I said I was going to talk about drugs. I'll talk only briefly about drugs. And just to show, this is some data. This is from the last year. This is 2010-2011 British Crime Survey of what proportion in each age group have taken any drug or any Class A drug. So any drug will include cannabis, Class A. Ecstasy counts as Class A, but Class A would be sort of heroin, cocaine, etc., like that. So we see, quite a large proportion of 16 to 19-year-olds, and it's steadily dropping over time. The point is, though, that those rates again are dropping now. It's lower than it used to be. Those rates are dropping. If we look at deaths, micromort. What's the risks of taking drugs? Well, a micromort is a way of measuring that. We can look at, over a period, how many deaths are named on the death certificate. These drugs are mentioned: heroin, cocaine, and crack cocaine, amphetamines, ecstasy, and cannabis. Is mentioned on that many death certificates. But in order to do a micromort, we have to know what the exposure is, how many people are actually taking these drugs. And that's very difficult to find out. Very difficult. They do British Crime Survey, but they ask people, are you taking heroin? In the last year, have you taken it? And, maybe people will be honest and maybe they won't. But essentially, what this shows is that you should not take heroin. It's a massive death rate per week. 370, that's 50 micromorts a day. That's like, 7 parachute jumps. This is really, really, really dangerous. Okay, so we can measure, but because you can be making these comparisons can be quite delicate. You may have heard the story of David Nutt, who is the government drugs advisor. And he made a comparison between taking ecstasy and going horse riding, the addiction to horse riding, which he called equasy. And he pointed out that the risks of taking ecstasy were rather similar to the risks of equasy. And in fact, they are, I think, ecstasy and equasy, and going horse riding, around about 1 or 2 micromorts each time you either take ecstasy or go horse riding. So they are actually rather similar. But by making that comparison, this was deeply socially unacceptable, and he got sacked. So I better not make that comparison at all. Okay, framing. Now, this is the other thing about risks and numbers, is that people are trying to manipulate you all the time. People are telling stories of number. So this is a wonderful bit of manipulation. I really like this. Was a poster on the London Underground, which I took. It was the 99% campaign, it was called. And it says 99% of young Londoners do not commit serious youth violence. So let's consider you as young Londoners. That means 2 of you do commit serious youth violence. Who are you? Where are you? No, I don't think it applies uniformly throughout the whole country. But okay, so 99%, and so that's a positively framed message. So there's a positive framing. Now, do the sums. How many young Londoners do commit serious youth violence? How would you do those sums? How many do commit serious? How many young thugs are there in this capital? Okay. So what you have to do is think, well, that means 1% of young Londoners do commit serious youth violence. There's about 8 million, population of London, about 8-9 million. That means about 1 million between 15 and 24. 1% of 1 million is 10,000. Oh my God. Yeah, there's 10,000 violent young thugs in this city. It's a terrifying statistic. But they don't tell you that. They don't say 10,000 young Londoners commit serious youth violence, but that would give the wrong story. So you've got to watch out all the time. How are the messages being framed? Numbers do not speak for themselves. It's how they're packaged give you the story. You've got to watch out for that all the time. Okay, so sausage rolls. That was my final bit of my talk, sausage rolls. Sex, drugs, sausage rolls. Let's do sausage rolls. Okay, now I put up, that's my favourite menu. That's my idea of a night out. Yeah, isn't that great? It's a really disgusting food. Who likes food like that? Yes. Oh, come on. Come on, you can't all be so worthy. Yeah, I know, come on, own up. Who likes that? Actually, that stuff is particularly disgusting, I think, if you're looking at bad food. Now, it's where, food like this is risky, but what measure of risk can we use? We can't really use micromorts. This isn't going to kill you on the spot, unless you sort of choke on your spam fritter because you're eating it so fast, if you can imagine. Such a disgusting thing. No, you need a different measure of risk. And what we need to do, because this bad food, is going to, in a way, harm our health. It's not going to kill us straight away. But if we keep on eating a bad diet, it's going to shorten our life in the end. And what people do is is measure things like, what does this do to our annual risk of dying? For example, they estimate that a daily portion of red meat, 80 grams, that's about that much red meat. So, that much red meat a day, they reckon, increases our annual risk of death by about 13%. And if it's processed meat, even more. 80 grams of processed meat, that's sausages or bacon, will increase our annual risk of death by about 25%. Okay, right, so what does that mean? Well, actually, when these sorts of stories are recovered, it says replacing meat with nuts thought to reduce the risk of dying by 20%. Well, we're all going to die sometime, aren't we? And some papers get it really badly. I don't think I read that out. The Daily Express said if people cut down the amount of red meat they eat to less than half a serving a day, 10% of all deaths could be avoided. Whoa! Isn't that amazing? You live forever. Just eat those nuts and 10% of you will never die. No, the newspapers do have trouble with this idea of risk. Okay, the basic foundation for measuring the risk of our daily activities is based on hazard curves. And this is the hazard curve. Because that 13%, what that says is every year, if we're eating all that red meat, our annual risk of death is going up by 13%. But what is our annual risk of death? Well, you can get this. The government published this. I think this is a great curve. That's for men, that's for women. This is the annual chance of not making your next birthday, on average. An average annual chance of not making your next birthday. So you can plot where you are on that, and it's a log scale. See, that's 1 in 100. Now I'm 62. There, it's about 1 in 100 60-year-olds don't make their 61st birthday on average. Usually they're sick already, so my chance of dying in the next year would be a lot less than 1 in 100 because I'm not sick already. At least I don't think so. 40 is about 1 in 100, 1 in 1,000 40-year-olds. The safest anyone has ever been on this planet since the beginning of time is a 7-year-old in this country or in Western society at the moment. And what do we do? 1 in 10,000 won't make their 8th birthday. Nobody's ever been safer in the whole history of humanity. And what do? Drive them to school in our big Range Rovers and coddle them and get really concerned about it. They have never been safer, for heaven's sake. So that's, you notice something, look, it goes down at 7. It starts with, babies, and sadly some babies die, and then it goes down to 7, and then it starts going up, and there seems to be a bit of a jump at 17. You wonder why. And I was very sad. This curve is a very, very powerful, I think, emotional device. Because look at the bulge, between 10 and 25. That bulge, that's the risk-taking bulge. And then it settles down. And that for girls, it's a lot lower. Notice the whole curve is lower for girls, all the way along. At every age, females have a much lower risk of death than men. Men have a 50% higher risk of dying each year than women do. Right from babies all the way through their lifetime. They are the weaker sex. Just remember that. They're pathetic. So that's for girls. The other thing you note, actually, is one that I love this. If you look down at this end, and it's a straight line pretty well. Apart from the bulge, risk-taking youth bulge, it's a straight line between about 10 and 90. What that means, since it's a sort of exponential scale like that, it means that every year your chance of dying increases by 9%. It just keeps on going up. Even if you start low and you're really healthy, it goes up and up and up. It's just inexorable. That straight line on this log scale, 9% a year, means your chance of dying doubles every 8 years. No matter how old you are, no matter what you do, how healthy you are, your chance of dying doubles every 8 years. Bop, 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 bop. That's why it gets you in the end, because it's this exponential growth in risk. There's something about our bodies. And that 9% works where it works in tribes, it works in America, it worked 100 years ago. It's something about us. We fall apart at 9% per year. And nothing we can, by our behavior though, we can move the whole curve down a bit. That's the trick. Or we can move it up a bit. So this study implies, the red meat study, that a 40-year-old eating a nice worthy veggie lunch can expect to live another 40 years on average. Now, his friend, who every day stuffs down a burger, okay, what's that going to do to his life expectancy? He's got this increased risk of dying each year. Actually, it only means a year off his life on average. It's not that, even though the annual risk of death is 13% higher, it doesn't make a massive difference to the life expectancy. And a famous author said, oh, I'm not going to give anything up for the sake of another year in a geriatric home in Weston-super-Mare. So what he's saying is that, well, why bother to do these things when it only means we live a little bit longer? And what that's doing is that psychological trick, which I think young people might have a tendency to, of just not bothering about what happens when you're old. I mean, do you think about when you're old? Do you worry about your pension? I don't think you do. So people don't, don't think, when I'm my age, you start worrying about this stuff a bit more. But young people don't. So how could we, what psychological trick, what framing trick could we take to bring the risks home to you young people? How could we do it? And people have thought about this a lot, because just saying you're going to live a year longer, people say, no, I'm not going to bother. So how can we do it? What you want to do is bring the impact of your behavior right down to the present. And there's a trick for doing that. We could say, well, a year off your life expectancy, a year off your life, an adult life, roughly 50, 55 years or something like that. You take a year off, that's 2% of your life off, which is pro rata, that's what 50, that's about a week in every year you're losing. Or equivalently, a 50th of a day is 30 minutes. So if you do something that's likely to take a year off your life, in fact, you're losing 30 minutes a day. You're taking 30 minutes off your life for each day that you have got that habit. So that brings it right home. You've got that, you've got that steak, you've got that bacon sandwich in front of you, you've got a cigarette, like that. Just think, now what's it doing? How much time is it taking off your life? And we've given a name to this 30 minutes. Now I think this is quite nice. That's a half an hour. 1 million half hours. Anyone know what 1 million half hours is? Why should you know what 1 million half hours? You have to be really quick to weather. It's about 57 years. This is you've got longer to live than that. I mean, on average, I would say about 40% of you are going to get to 100 at least. So you've got more than 57 years. Well, I haven't got 57 years to live, but someone now in their 20s, 30s got about 57 years to live, a young adult. So 57 years is 1 million half hours. So we call this a micro-life. 1/1000th of an adult life, half an hour. So you are frittering away by watching me today, 2 micro-lives, 2/1,000,000ths of an adult lifetime you waste. So you sit down and watch television or play some games or watch something on YouTube, every half hour, that's 1/1,000,000th of an adult life. Imagine it, just gone like that, poof. And we're at 48 a day we're using up. Bam, 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 48 a day. But by our behavior, we can use them up either quicker or slower. So on average, you can lose a micro-life, that's in other words, lose 30 minutes off your life from a burger. So the lesson is eat it slowly. Enjoy it, because it's half an hour flow. Bacon sandwich, an hour off your life on a bacon sandwich. I love bacon sandwiches, but I now eat them fairly sparingly. But I do. It's a known carcinogen. Bacon is a known carcinogen. It's in the same carcinogenicity category as cigarettes. However, I still like it. So you can consume carcinogens, but you've got to think the pleasure has got to be worth the risk of it. Okay, drinking, yeah. Drinking about a unit of alcohol, a standard drink, which is about 2 units, it's a glass of wine or a can of fairly weakish beer, is half an hour of your life. So that, again, if you're going to have a drink it slowly. So, and cigarettes. So, yeah, 2 cigarettes, about 15 minutes each cigarette. So if a smoker who smokes 20 a day is about losing about 9-10 years off their life on average. That's 5 hours a day. So instead of going towards their death at 24 hours, they're going at 29 hours a day. Actually, they're not running because they're gasping too much from the cigarettes. So that's half an hour. And then, no, I'm slightly embarrassed about this. So those of you of a nervous disposition may want to look away at this point, because I did get a body double for this. Being 5 kilograms overweight, which is what I am, is associated again with this increased risk equivalent to losing about half an hour a day of your life. Okay, so let you be warned. But all the other things, if you cycle, good diet, you can save 2 hours a day on your life, put it on, by having a good diet, by exercising. The first 20 minutes of exercise is an extra hour in your life. Actually, the next half hour of exercise is only half an hour in your life. So you better like exercising, because all you're doing when you're exercising or when you're cycling is time is stopping still for your body. You're not aging at all while you're cycling. Isn't that cool? I like that analogy. Okay. So the message from this is, if you want to live longer than your friends, eat and drink nice fruit juice. But if you do live longer than your friends, you won't have anyone to talk to, but never mind. You can play on your iPad. So, now the wisdom bit. Now, this is the one I say, take risks. Yes, I'm a professor of risk. Professor of risk encouragement, take risks. It's a great thing to do. But don't be stupid. Before you take any risk at all, doing anything, and risks are all sorts of things. There's social risks you can take. You can change your friends. You take up new enthusiasms. There's all sorts of risks you can take, not just physical ones or money or financial risks. But don't just plunge into it. Stop. Consider the possible consequences. Set an aspirational but not ridiculous target, like me trying to do Wipeout, and take precautions against possible severe loss. So don't do reckless things. Don't be reckless. Take risks, don't be reckless, and then go for it and have fun. So that's my little bit of wisdom. You may fail, but at least you'll learn. Don't be reckless. That's me on holiday in Greece a couple of years ago. And what I always say is that is not the time to be thinking, I wonder how deep it is. Make sure someone has jumped in first, if necessary by pushing them. So it was great, but I was cautious. In fact, I was very cautious. I waited till lots of people had done it. Okay, so there's my little lesson in life. And what I'm going to do now is to show how these noble lessons that I'm portraying to you, actually, whether this made any difference about how I got on in Wipeout. And I'm now going to show you that, if you're very good and if this works. Okay. Right.
The 12 remaining competitors must mount the ski lift and do their utmost to remain standing. To help them, they have a podium to perch on and a bar. Finally, it's Professor David Spiegelhalter, OBE.
What am I doing here? I don't stand a chance.
It's snowing!
It wasn't, it was boiling
Ski
hot.
pole arms have started.
Oh, and they're off!
Now, they will need to jump over both arms, which get raised up as the game goes on. Remember, the last 5 still hanging will go through to the next round.
Oh, Professor Spiegelhalter.
I don't stand a chance.
All making light work of those ski poles so far. And there's Professor Spiegelhalter, OBE, Rob Boy. Those poles are getting higher now. There's John. And John again.
There's a few gone.
And James.
I think there's 4 gone.
They are not letting
The
go.
last 5 go through.
There's Mel. Oh no, Mel!
Oh, Mel.
Really tense now. The next 2 to 4 will be out of the competition. Marina, Suspicious Helen,
7 left.
Professor Spiegelhalter, OBE.
No, look, they stop it. They stop it.
Just presenting himself to that arm now. So dignified. So Professor Spiegelhalter, OBE, is the next victim of this first ski lift.
Well, at least I gave it a go. So thank you very much indeed. Yeah. I'll take questions, yeah.
Spiegelhalter, then I think I'd like to ask him now if you want to speak to him on his own after the talk. Has anyone got anything they think everyone else would like to hear?
what a terrible thing to ask. Yeah. Yeah. What is it?
You know how you said your body sort of stops timing people exercise?
Yeah.
Does it mean if you exercise forever, you can live forever?
Live forever. Yeah, no, exactly. The logical thing for that, if you keep on cycling, you'll never die. Because time will have stopped. No, you'll probably get run over before that will happen. That's the problem. Yeah, no, it only works for the next half hour a day. Then you gain half an hour. If you exercise more, it's hardly any benefit at all. The benefit from exercise is highly non-linear. The first 20 minutes each day when you get up off your backside, out of the sofa and get moving is enormously beneficial. The next bit is quite beneficial. After that, it really doesn't do much, and of course there's some suggestion it even starts looping up, and that over-exercise can be harmful for your long-term health. So actually, yeah, there's a point where you're getting exact return of what you're putting in, and then even diminishing returns. So you exercise for half an hour and you only get a quarter of an hour extra in life. But of course you may feel better and enjoy it. You maybe not be doing it just because you want to live longer, but because it's making you feel better. Cool, yeah.
If I eat my bacon sandwich while I'm cycling, will that cancel out?
Yeah, no, exactly. No, but that's the problem with this thing of weighing them up. Some of my public health colleagues don't like this sort of metric of adding things up because they say it encourages people to go to the gym, come out of the gym and go straight into the pub, which of course is what I always used to do. So, but the problem with the bacon sandwich is you're likely to get knocked over. Now, cycling though is a fascinating one because there's a trade-off between the acute risk of cycling along 20 miles on a micromort and the chronic benefit in terms of your exercise. And so people have done a lot of analysis of the trade-off of that. Should you be encouraging people to cycle when you know that it will lead to more accidents on the roads? It's almost guaranteed. I mean, you should put in better infrastructure, but in the end, probably there'll be more cycle accidents. And they reckon it's quite difficult calculation, about a 10-to-1 return in benefit. So although you experience some micromorts, the micro lives you gain from cycling cancel them out by about 10-to-1 on average. And that's assuming you're not a stupid cyclist and so on. So, there is this trade-off, and the analysis suggests they are roughly, you can sort of trade these things off. The really interesting one, I think, which I didn't put in there, is which I should have put the fifth picture, after me holding my belly, should have been me sitting on the sofa watching Downton Abbey, or whatever. Because each of the other thing that costs you a microlife is 2 hours of sitting, sedentary behaviour. And that's a lot of research going now into sedentary behaviour. That's not sleeping and thing. That is just sitting on your backside, doing nothing. And that, for reasons that I think people are still trying to understand, is particularly harmful to you, just sitting. That's why people are going over to standing desks, trying to get so that people don't use the lifts, moving around, standing meetings, so that people are not just sitting down all the time. And watching television is really quite a dangerous activity in this sense. So if you watch Downton Abbey for 2 hours, you've not only wasted the 2 hours there, you've also taken half an hour of your life. So let that be a warning to you. Yeah. Yes.
How many micromorts does someone experience from spending a day at school?
Oh yes, no. Probably, actually being in school is probably fairly safe because you're all covered by health and safety. It depends how you get to school, and whether you cycle, you walk, or something like that. Probably, pretty low risk you'd be, and probably among you lot. It's probably less than 1 micromort a day, I'd say, because you probably live fairly safe lives in a fairly safe environment. But the point is, though, that we do take risks all the time. Every time you go out the door, something could happen. You always read of these accidents, because all, freak accidents happening. So, the 1 micromort a day is not a bad rule of thumb that we're all prepared to put up with. We don't stay in bed quivering because, the fear of the 1 micromort a day. Yeah, it's interesting. The other thing is 1 micromort, they reckon, is the chance of being killed by an asteroid during your entire lifetime. So that's why, don't worry. There's no point in worrying about what's coming out of the sky, because it's it's only a day's worth that you have over your whole lifetime from the asteroid in the sky. So what it shows, though, is that we do live with risk all the time. We live with uncertainty. We don't know what's going to happen. I know we quite like that. We don't want to know what we're going to have for Christmas. Actually, maybe you do know what you want to have for Christmas. Who would like to know? Imagine I am an all-knowing being, and I can tell you how long you're going to live. Who would like to know? Yeah, any more? Oh, not that many. Yes, okay. Usually it's more. Usually it's about 10% people would quite like to know. Why would you like to know? Sorry? So you can plan, yeah. Why would you like to know? Because you can plan. It's no good if I tell you it's tomorrow, is it? But I'm not an all-knowing being, so don't worry. I can't. But the point is that most people actually live without uncertainty. We don't know what's going to happen in the future. You know, maybe you can guess pretty well what's going to happen tomorrow at this time. You can probably work that out. Maybe next week, next year, all goes very blurry. What are you going to be doing next year? 5 years' time, 10 years' time? You don't know. You don't know. And that's fine. You know, who would want to know? So I think that, you know, you've got to acknowledge that living without uncertainty, risk, is just part of our everyday life. And we just have to, actually it's part of being human, is living with that. And as I said, though, the crucial thing is to live with it, enjoy it, but don't be stupid. Because that's a bit silly. Yeah. Not I think you would be stupid. I'm sure you wouldn't be. Yeah. Sorry? Optimal amount of sleep? Oh yes, sleep is very important. No, quite a strong risk factor for people who have 6 hours or less a night. I think it's quite an increased hazard ratio. That curve goes up. It really is quite an increased risk. And similarly for people working night shifts and things like that, have a long-term chronic effect on your body, a lack of sleep. So really, no, you need 7-8 hours sleep a night.
Too much.
Oh, too much is pretty bad as well. It's one of these U-shaped things. Yeah. I can't remember the exact figures, but people have done quite a lot of research on that as well. So all these, you know, the problem is you end up with all this advice which just sounds like, oh, is that all? You know, it's just advice. It's sort of don't drink too much, don't smoke, exercise, have a decent diet, get a good amount of sleep, don't get stressed. And you go, oh, yeah, so what? But it's true. These are the important factors that actually enable you to live a long and healthy life. Yeah. Oh, yeah, and so just final plug, do maths. Maths, you don't have to do this stuff I'm talking about. Whatever you just do maths, doesn't matter if you do stats. But as I said, the stats business is very interesting. The future with there's so much data around now. A lot of interest in it. When you think of how this sort of stuff I'm talking about, how increasingly how much data there will be about people's habits, people's exercises, what they eat, and so on. And someone's got to look at all that lot. Okay, thank you.
Everyone, if we could just join in a big round of applause for Professor Spiegelhalter.
That's one thing. Sorry, another quick plug. I'm sorry. I'm on television tonight at 8 o'clock on Sky Arts in a program called Computer Says Show, which is about computer-written musical that's currently on in London, and which I had a part in planning and doing the stats for. So if you happen to have Sky Arts and you want to see that, I should be on that. I think it'll be quite a good program. Okay. Final plug. That's the last plug, promise. Okay.
Thank you very much.
Thank you very much.